All right, we're going to continue our unit on exponential functions and logarithms, and to do that, we're going to jump into probably my favorite thing of all, which is called compounding interest. But for the sake of this chapter, of course, I disagree with how the textbook does things, but for the sake of this chapter, we're going to stick with only continuous compounding. I'm going to use this question, and I'm going to actually go over some realistic applications of the concept, so that way I can sleep at night knowing that I've done my best to prepare you for the dangers of the financial world. Anyhow, here's the word problem. We're going to say that we have $2,000 to invest into an account that earns 5.1% annual interest, and the question is, how much would the account be worth after 3 years if it were compounded continuously? And you'll hear, I'll tell you later about why this is completely unrealistic, but after you cash out this account in 3 years, go buy your unicorn, because that's just as realistic as this problem. Anywho, we get into this concept of compounding interest. And so we have to talk about compounding interest. And what that is when an account is able to take interest and basically reinvest it, or in more applicably recharge it, and then build more interest on top of the interest that's already being built. And so you have this whole concept called compounding interest. Now, if an account were to compound continuously, that means every second, every millisecond, every millisecond, every time, like every unit of time imaginable, the interest on an account is compounding. You have this thing called continuous compounding, and the way the formula works for that looks like this. You have this crazy looking formula, and there's our buddy E, which is why I spent so much time on that first problem on the previous unit. So you have this crazy formula from continuous compounding, and the way this works is you have the A, the capital A, which stands for the total amount that we'll have after. Okay, so we'll call it the amount in total that we'll have after this money has been compounded continuously. The P stands for the principal amount, which is your starting amount. Okay, so that's your starting amount. Our E is our good friend E. This is the E that we met just in the previous lesson. So the E is actually E, that exponential constant. Okay, the irrational exponential constant that exists. Like I said, it exists in nature, and that's the E that we know. And then the E is being raised to a power. It's being raised to the power of RT, where R stands for the rate of interest. And here you have to be careful when you're talking about interest rates. You have to make sure the difference between decimal versus percentages, because this R is going to use the decimal. And then the T stands for time, okay, the time in years. And this is the formula that we use to figure out compounding interest if it's done continuously. Every millisecond, every amount of time, like the interest keeps compounding and rebuilding upon itself, which is why it's fake. This is totally unrealistic. But since it uses E, this constant of exponential growth, we figure, hey, let's show you how to do it here. When we're done with the problem, I'll do a more realistic situation for you, and then talk about other stuff. So this is the formula, and we call it Pert normally for short, because it kind of looks like the word Pert. But basically, it's the Pert formula, the principal times E raised to this power, and that's going to be your total amount. And so we're going to use that formula in this situation, and it's clear to read. Let's say we invest $2,000 into an account. When you read that sentence, hopefully, if you understand what it is that you're reading, you realize that the $2,000 is your original investment. So in this case, that $2,000 that we're dealing with is our principal amount. Okay, so just from reading, which is the key to most stuff. So you read and you realize, hey man, that $2,000, that's the principal amount, okay? And it's into an account that earns 5.1% annual interest. That's your interest rate. Okay, so 5.1% is your interest rate. Now, watch how I'm going to write that down. This is the interest rate. It's not this R, okay? It's not this R. The R is actually going to be the decimal of the 5.1%. So the R that we're going to use, this is where you have to be careful, is 0.051. And you have to see the difference between the interest rate versus the decimal that you use, which is why on the note, R stands for rate of interest, and make sure you know the difference between decimal versus percentages. So even though 5.1% interest is the interest rate, the R actually that we're going to use is 0.051. Which is quite, as far as realistic stuff goes, that's pretty good. I mean, that's a really good interest rate. If you can find that in real life, take it. That's not bad for an account. Okay, so that's pretty darn good. Anyway, so back to the problem. We know our $2,000 is the principal. We know the 5.1% annual interest is the interest rate. So the question is, how much would the account be worth, right? How much total? Basically saying we're looking for how much the account will be worth. We're looking for A, after 3 years, if it were compounded continuously. Okay, so if it were compounded continuously. And so clearly that 3 years is our T. Okay, so we know that the 3 is the T, and since we're saying compounded continuously, that gives the indication that we are using our Pert formula, that we're using E. E is the giveaway for compounding continuously. And I'll show you other stuff. So the rest from here is plug and chug. This is how easy, or not easy, this is how simple, straightforward compounding interest is when you're dealing with continuous compounding. When you're dealing in fantasy, it's actually quite simple. So we know we're dealing with our Pert formula, and we know we're looking for A. We know we're looking for the total account, and so what we have is our $2,000 is our principal. So that's our principal amount, and we know we're multiplying that by E raised to some power. Okay, and the power is the rate times the time. So again, we're using the decimal for the rate and the time. Okay, so we're just going to figure this out. So you can do it piecemeal, or we can use our handy-dandy calculator. Okay, so we can jump right into the calculator, and just like in the previous lesson, I'll show how parentheses work. We can actually plug this whole thing in if we're doing it very carefully. So we can say that we're going to start with 2,000. There, that shows up a lot better. And then we're going to multiply it by E, and there you look for the button E. Okay, and it's being raised to a power. Now, before I start typing in 0.051 and 3, I'm going to use parentheses. Remember, we have to account for multiplication. So look at how I've typed that exponent in. Okay, so I'm using parentheses. That's telling me that that exponent is something complicated. So I've plugged, I've chugged, boom, hit enter. That's how much the account is going to be worth in 3 years. Okay, so in 3 years at 5.1%, you're making, $331 is basically how it goes. So let me do some talking, or more talking here. All right, so after plugging and chugging, we find that we have the A is equal to 2330.649958. Okay, but just remember, we're dealing with money here. Okay, so we're actually dealing with money. And remember, with money, we have to do some rounding because we only have cents, right? Dollars and cents. So the actual dollar amount that we would have in the account is $2,330.65. Okay, so basically in 3 years, the account has earned $331 without doing anything, and that's kind of magical. Okay, so that's the fantastical element. Okay, so for a lot of the students always ask, "So are we done? Is this the answer? God, can I stop learning now?" Yeah, all right, fine, we're done. If you are interested in learning, and if I'm playing this in class, you're going to deal with it and learn anyway, darn you. We're going to learn how this is more realistic. So this is it for continuous compounding, right? Are we done now? Yeah, you can be done, but I'm going to teach you some real life stuff. Okay, the real life formula that is used for compounding, because compounding interest is very real. The real life formula for compounding interest is actually a bit more complicated, but it looks familiar. Do you remember yesterday or in the previous lesson, whenever that was, I'm not saying, we sketched the graph of some kind of function that was this, and that's how we met our exponential constant e, right? Remember that? Well, the formula for compounding interest is actually this. So you have your total amount that you're going to get. Once you've invested a certain amount of principal, looks like this. That is actually the formula to figure out compound interest, okay? And so we have to do some parameters. Principal is still principal. Rate is still rate, okay? That's the same rate still in decimal, okay? But what is this n? Okay, so n happens to be the number of times that the interest is compounded in 1 year. Okay, so it's there again. The fantasy is this whole continuous compounding thing. So there is no such thing in reality as continuously compounding, because even if I compounded an account every millisecond, that's still not E. That's still not continuous, because it's even faster than that. No one does that. The most aggressive compounding in interest occurs in credit cards, and the credit cards compound their interest daily. So if you ever encounter a situation in finance where you're able to invest a certain amount of money. So let's go back to this. We're going to play the same investing. We're going to still invest $2,000. We're still going to have an account that earns 5.1%, and we're still going to do it 3 years. But since there's no such thing as compounding continuously, that's fantasy. I'll even be aggressive. The more realistic compounding, which again is still very aggressive. Let's say it's quarterly or 4 times a year. Okay, so let's say it's compounded quarterly, and that's super aggressive in an account, and that's quarterly means 4 times a year. And we're going to see in the more realistic example with this whole situation what would happen. And by realistic, I mean, man, if you can find an account that's going to pay 5.1% interest compounding quarterly, dude, grab that. Throw your $2,000 into that. That's pretty good. So let's see what we would have. Everything else remains the same. Okay, so we have our A, our total account is the principal, still $2,000. Okay, and then we have 1 plus, now the R is still the R, 0.051. Okay, divided by n, the number of times being compounded per year, which is 4 if we're doing quarterly. And all of that is being raised to, again, the n times t, the number of years. Okay, so this is what we would end up putting into the calculator to decide what would happen. So let's do some calculator work, and we'll do the same type of thing. Okay, so turn it on. There was the previous result from the fantasy question. So now what if it was reality? So I'll use 2 parentheses now. So now it's 2,000 times, all right, so I'm going to do, this is going to be crazy, 1 plus, I'm going to use another set of parentheses for the 0.051 divided by 4, okay, and I'm going to close that parentheses, and I'm going to raise that to a power, which of course I'll use more parentheses, 4 times, or I could have put 12, but it doesn't matter. We'll say 4 times 3. All right, so this is the reality, all right, this is the more realistic amount that we would get. So plug that in. Like I said, that's still really aggressive. So in 3 years, if your account is doing nothing and you're compounding quarterly, the actual amount that you would have is $2,387. $28.40. Okay, so compounding quarterly, the more realistic is here. And then that's what would happen if you find an account like that. Now let me turn the tables once more. So this is if you make money. Okay, so now let's pretend that you are dealing with credit cards. So I'm going to teach you about the danger of credit cards. Let's say you had the same thing, $2,000 in debt, okay, in credit card debt. And let's say the credit card company was charging 5.1% interest rate. Why am I laughing? Because the reality in interest rates is more like 19%. Okay, so read your thing. So you're going to carry $2,000 in debt. Reality is that. Now, what does a credit card do? They compound their debt daily. Okay, so they have daily compounding. All right, so a credit card will charge you debt by daily compounding. So that means N is 365, right? So using the actual formula, which the book doesn't test you on, boo, but I'm going to show you anyway, yay. Okay, so I'm going to show you anyway. If we were to use that formula, what would happen if this were a credit card company? Okay, so we'd have the whole thing, and it's still $2,000. All right, then 1 plus the interest rate. Again, credit cards work with 19. You know what? I'm going to use the 19% because that's more realistic. You don't have that. You have 19% credit card. Okay, so 0.19 over 365 because that's the number of times credit cards compound their interest. Okay, and that's being raised to the 365 times 3. Okay, so this is what a credit card would charge you. So you have to be aware of that, and that's what we're going to plug in. Okay, so let's figure out what the credit card company will charge. So I'll get it so where you can see it. Okay, so here we go. I'm going to do the same thing. $2,000 in credit card debt, and the formula they use is the same formula. But since they're charging it a 19% APR, which is more realistic, that's going to be there. We're going to raise that to daily compounding, 365 now times 3. Okay, so what would be your total credit card debt? Your total credit card debt from that $2,000 being daily compounded is going to be, so in 3 years, blam, right? In 3 years, look at that. On a 19% APR, you're going to have a crazy amount of credit card debt. And they compound their interest daily. So you have to know that about credit cards before you start thinking it's an endless source of money. So your $2,000 debt in credit cards, after 3 years, if you don't make any payments, and even if you do, they don't care because they're still going to make a whopping on you. All right, so just be careful when you use credit cards, please, because credit cards use Algebra 2. So I've waited all year in Algebra 2 to finally tell you where you're going to see this stuff. Where am I ever going to use this? It's being used on you now. Okay, so just be careful when you start dealing with credit cards. And that's it. Thank you so much.